Okie dokie. So we are moving on with multiplying, dividing rational expressions today. So this one's fairly simple. This is just a straight up expression. Wants to simplify it. And when it says state any restrictions, it's another way of saying like give the domain or basically what values can you not put into this function. So first step, you need everything factored. So looks like we're going to need to go x minus 3 and x plus 2 here. Down here, we can pull the x out. That'll knock all the powers down one. And then factor negative 18 that add to 3, we'll need to use 6 and negative 3. So x plus 6, x minus 3. At this point, do your restrictions. What can that domain not equal? Well, it can't be 0, can't be negative 6, can't be 3. And that's it. That's what we're looking for in terms of the restrictions. The last piece is the simplifying. Do we have any common factors? Yes, we do. The x minus 3 would divide itself out. And then this is going to be our answer. So we can just clean it up a little bit here. And there we go. All right. Now the next little bit here, going back to just a guess. I think this is like middle school, but probably like 6th-ish grade maybe. Dividing fractions. And what you probably learned when you learned how to divide fractions was you learned about a little move called invert and multiply. Because dividing a fraction is actually kind of a weird thing to think about. But what it's equivalent to is if you change it to a multiplication problem, you invert, and this is the exact same thing. The reason why this is nice is this is easy to do. Multiplying fractions is the easiest of fraction operations. We froze. Never mind. So what I was saying is multiplying fractions is the easiest of all fraction manipulation there is. So you just multiply straight across. So 5 times 3 is 15. 7 times 2 is 14. We'd look to see if this can reduce, but it can't. There's no common factors there. So sweet, looking good. Same process here. In order to change it to multiplication, we invert. Looks like this. 5 times 4 is 20. 9 times 1 is a 9er. And that one does not reduce either. So, if they were both divisible by 2 or 3 or 4, we would do that. But in this case, they are not. So remember this little invert and multiply trick. We are going to use it with polynomials in the notes today.